Hello, my name is Eduardo Perez, and the purpose of this video is to show you how to use the PER viewer. The PER viewer is a tool for missense variant interpretation. Briefly, we compare the missense variant distribution or burden observed in the general population with the one observed in patients. When the burden difference between population and patient variants becomes significant, we're able to call a pathogenic enriched region, or PER. In the present tool, PERs can be explored across genes and gene families. So let's begin. At the start, you will see the search bar where you can type your gene of interest. Any gene will yield a result. For this example, we're going to use the SCN1A gene. Once you press submit, the app will show you the results. If the gene belongs to a family, like in this case, family-wise results will be shown first. As we can see, the SCN1A gene belongs to a family of 10 members. The first plot is the missense burden analysis for the whole family. On the x-axis, you see the protein sequence alignment of all 10 genes belonging to this family, which in this case is 2800 amino acids long. On the y-axis, we see the burden of the general population in green and the pathogenic burden of patients in purple. In this case, we were able to detect 15 PERs. We can see here their corresponding adjusted p-values. The deeper the PER signal go, the more significant it is. You can further explore the results in the table browser, as shown here. If we select, for example, this particular region, the table will get updated. You can see here that each column represents the protein sequence of each of the genes belonging to the family and their corresponding amino acid positions. Thus, each row corresponds to an analogous amino acid site that you can directly observe the degree of amino acid conservation. You can also see the clinical phenotypes annotated in these regions for each of the corresponding genes. We see here that sometimes we aggregate different diseases in different genes, like in this case, for example. If the aligned region belongs to a pathogenic enriched region, we see the alignment shown in red. If you want to further explore the PER main features, you can switch to this tab. You can see here the effect size of all PERs detected. If you click on each one of them, you can see in the right which genes are contributing to the signal and how many pathogenic mutations were found within them. We can also observe that for PER2, these are the most recurrent disease terms annotated to this position. This information is available for all pathogenic enriched regions detected here. Going back to the table, all the results are available for download. And if you're interested in the amino acid conservation of this entire alignment, we also provide the parallel conservation graph, as shown and reflected here by the PALACY score, which is a measurement of the degree of conservation of the amino acids in all the alignment. We can see here that this amino acid conservation is highly correlated with pathogenic enriched regions. As the higher the values goes, the more conserved is the amino acids. Finally, after you're done with the family-wise analysis, you can always switch to the gene-wise analysis available for all genes belonging to this family. The same information is provided here. We can see here the burden, the missense burden analysis for SCN1A only, and also the table alignment. And this is available for all the genes. So, I hope you enjoyed this tutorial, and feel free to reach us in case you have any questions or suggestions. And of course, you're welcome to look in deep into our methods and results in the preprint version that it's already available on bioRxiv. Thank you.